Good morning all. Now we will discuss some problems on basic electrical circuits. Now see here in this first problem we need to calculate R input, that means input resistance, right? Now first observe this circuit diagram. Okay, see here this is repeated, that means this series combination 1 ohm 1 ohm 1 ohm is repeated, right? That means this circuit can be redrawn like this. Okay, that is 1 ohm 1 ohm, here 1 ohm, right? Here 1. Next, this representation will be replaced by only single resistor, that is indicated with R in. Okay, input side also R in. Okay, that means this R in in parallel with this 1 ohm. Okay, resultant value will be 1 into R in by 1 plus R in, right? After that, this resultant value is in series with this 1 ohm and this 1 ohm, right? That R in is equals to 1 plus R in by 1 plus R in. If you simplify that equation, you will get R in value. Okay, after simplification you will get a value as 1 plus root 3. Okay, that is about first problem. Next problem, what is the current? Right, in the second problem here I need to calculate current I1. Okay, in this problem first you need to identify the number of junctions present in the circuit. Okay, if this short circuit path indicates a common path. Okay, now see here this path, this point and this point will be same, that means these two are the same junctions. Similarly here this point and this point is same, right? That means assume here it is node A, here it is node A. Okay, here it is node B. Okay, this B is same as this B. Next this A is same as this A. That means total possible nodes are only 2. This node and this node will be same, right? Now see here between A to B or B to A, clearly observe this waveform. A to B current source and A to B current source, A to B 1 8 ohm resistor and A to B 116 ohm resistor and A to B 12 ohm resistor. Okay, from that circuit, that means this circuit is having only 2 nodes, right? That is here node A, node B. Okay, from A to B one current source that is in downwards direction. Okay, similarly again A to B current, so another current source is connected, that is also in downwards direction. After that 3 resistors are connected in parallel. If you simplify the circuit like this, you will get the circuit. Now see here 2 current sources are in downwards direction, right? 4 amperes 9 amperes, this resultant value is 13 amperes. Okay, if I redraw that circuit, 2 current sources are replaced by single current source, that is current source 13 amperes in parallel with 3 resistors. Okay, that means here we need to calculate current flowing through 8 ohm resistor, right? That means here 16 in parallel with 12. Okay, that means 16 into 12 by 16 plus 12. Okay, after that here you need to calculate current flowing through 8 ohm resistor. That is current flowing through 8 ohm resistor is equals to total current. This total current is in downwards, right? Then the sign will be minus I into opposite parallel branch resistance divided by, right? Here these two resistors are replaced by single resistor, right? That opposite parallel branch resistance divided by sum of parallel branch elements. Okay, current division rule is applicable in parallel circuits, right? If you simplify that problem, you will get the answer is minus 6 amperes. Okay, that is second answer. Okay, that is about second problem. Okay, next, third problem. Calculate capacitance between A and B terminals. Okay, now see here. In between these are the two plates, right? That means this is A plate, top one is A, bottom one is B plate, right? In between A and B plate one capacitor is formed. Okay, that is one capacitor. Similarly, in between these two capacitors another capacitor, that is also between A and B points. Okay, right? Similarly, between these two plates, okay, between these two plates also one capacitor is formed. That means this circuit is having again only two junctions, right? That means node A and node B. Okay, in between A and B starting one capacitor is formed. Again in between A and B another capacitor. In between A and B only another capacitor, right? That means here three capacitors are connected in parallel. When capacitors are connected in parallel, total capacitance will be added, C equivalent. That means three capacitors will be connected in parallel, then C equivalent will be C plus C plus C. You will get the resultant value as 3C is the answer. Okay, next, fourth problem. Find the current Ix in the circuit shown in figure. Now observe the figure. Here current flowing through this branch is given 5 amperes. Okay, that current is towards the node. Next, see here potential difference is given. That means voltage across 6 ohm is given. The resistance value is given, right? Based upon this potential difference, the polarity will be, current direction is towards the ground. Okay, then the current is 12 by 6. You will get 2 amperes, right? 2 amperes current is flowing through the 6 ohm resistor. Okay, already current flowing through resistor RA is 5 amperes. Here current flowing through 6 ohm is 2 amperes. That is downwards direction. Okay, now if you apply KCL here, what are the outgoing currents? Ix and 2 amperes is outgoing currents, right? That is Ix plus 2 is equals to 5 amperes. Then Ix is equals to 5 minus 2, right? You will get 3 amperes is the answer. Okay, see here the answer is 3 amperes A. Next question, find the value of resistor R. Okay, now observe the figure. Here current flowing through 5 ohm is given, right? Here current flowing through 5 ohm is given. Okay, now see here, by using nodal analysis, here I can calculate node voltage first. Assume here all are outgoing currents. These two are outgoing currents. Assume small I1, here small I2, right? Here 5 amperes current source is given, right? Apply nodal analysis at this junction. Okay, I1, I2 are the outgoing currents and 5 amperes also outgoing current, right? So I apply KCL here. I1 plus I2 plus 5 is equals to 0, right? Then I1 plus I2 is equals to minus 5. I1 is nothing but potential difference. This node potential is, assume V minus 50 by 1.5, right? Here potential difference V minus 50 by 1.5. Here potential difference will be, ground is having 0 potential, that is V minus 0 by 41. Okay, first you need to calculate node voltage V. Okay, once node voltage is calculated, after calculating node voltage, see here, once node voltage calculation is over, here we know the node voltage, right? That means Node voltage is nothing but potential with respect to ground, that is nothing but voltage across this resistance R. Okay, node voltage is nothing but voltage across resistor R only here. That means voltage is known, right? Then R is equals to V by I, right? If you simplify this equation, you will get current value as 8.2 ohms. Okay, next question. The voltage V in the figure always is equals to, see here in this question he is asking to calculate voltage at these terminals, these two terminals, right? That means we need to define voltage across current source, right? But practically across current source we cannot define voltage. Okay, hence the answer will be cannot be determined. Okay, across current source we cannot define any voltage, hence we cannot determine. That option D is correct. Suppose in this problem, suppose if he ask voltage across these 2 points, from these two plus minus, then current flowing through 2 ohm is 2 amperes, right? Now the voltage across, if we ask here, you will get 9 volts is the answer, that is 2 into 2. Okay, based upon this current direction across passive elements, polarities are plus minus, right? That is plus 4 and plus 5, 9 volts is the answer. That is first one is the answer, but he is asking at this point, right? Hence we cannot determine the voltage. Okay, next find the voltage in the circuit shown in figure. See here our aim is to calculate voltage across the 3 ohm resistor. Okay, already we know that in parallel voltage is same, right? Okay, across resistor also polarities will be same as supply polarities, right? Here polarities plus minus, here polarities also plus minus, right? Both are same. Then in parallel voltage is same, then voltage across 3 ohm resistor is 2 volts is the answer. Okay, next problem. Find the voltage in the circuit shown in figure. Okay, see here in the given problem, voltage source is given and current source is given. When these two sources are present, we need to give priority to only current source. Now see here, based upon this current source, polarities of this polarities will be minus plus, then across polarities, across this resistor polarities will be actually plus minus, but in the problem is given minus plus, right? That means the voltage across this branch will be reverse. That means actual voltage is based upon this current I into R, right? That is 3 into 1, 3 volts. But actual polarities will be based upon this current direction. We need to get plus minus, but here in this problem is given minus plus, right? Hence the voltage across this branch will be minus 3 volts is the answer. Okay, next find the voltage in the circuit shown in figure. Now see here I need to calculate voltage across 3 ohm resistor. Now see here again, here polarities will be here minus plus, based upon the supply polarities across voltmeter should be, that means across resistor should be plus minus, but he is given in reverse polarity. Okay, then this voltage value again minus 3 volts, right? That is second option. Okay, similarly you can solve this problem. Okay, remaining we will see in upcoming classes. Thank you all.